They're up here at the front. Okay, so electrons is where we're working now with the general chemistry. We're in Unit 3. What we've done in the past, or what you've done in the last couple days, let's go back here real quick. You should have done the POGL when I wasn't here. If you haven't done that, you need to do that and upload it to it. It says Daily Work 3.1, but it says POGL on it. So just upload it to that. You should have taken quiz 3.1. Today, by the end of the period, take 3.1 and 3.2, because I know that wasn't published. Today in the lecture, this is just sort of a preview what we're going to talk about. We're going to talk about orbital notation, electron configuration, and noble gas configuration. It's all about where the electrons are in the atom. So those are fancy words, but that's what we're going to do. So we are going to have your periodic table out in front of you. And you can use pencils or you can use crayons. I don't care whichever you are more comfortable with. We are going to shade it. So I would like you to shade it like this. Whoops. Hopefully it will come up in a minute. So get that out. We're going to talk just a little bit about this. You can use a pencil and just outline these areas, because we're going to fill them in with other things later. I don't want you to color this one in. I want you to just outline it. So metals in purple, just outline the area in metals in purple. And that purple actually comes down into here and also the two at the bottom. So just outline it. Don't color it in, just outline. There's another periodic table by the Gen Chem. Great. Okay, metalloids, these are important. These just outline in red along here. So there are 7 of them. Boron, silicon, germanium, arsenic, antimony, tellurium, and aluminum. So just outline them. Do not fill them in. Just outline them with the red. And then the nonmetals we're going to do in the green. You'll notice that hydrogen's included in the nonmetals. Hydrogen's sort of like a fence sitter. It goes metal or nonmetal depending on who it's with. So it plays both sides of the game. So if you get down the metalloids right here in the center, and you'll notice it's like a staircase right here. Okay? It's a staircase coming down. And then just go back up, and the middle two right here have a support. So if you'll outline those, on the left side are your metals, on your right side are your nonmetals. Okay? And then just put a little key at the top somewhere here, like metalloids. Like that. And then do it with the green for metals. Do it for the purple for metals. I only have blue, so I'm just going to put blue. Metals. And then the green for the nonmetals. So you know what you've done. And you can also say that this is an outline thing, kind of somehow. Because we're going to be putting other things on there. Just do it really quickly. Do not shade it, because we're going to shade other things. So at this point, I probably wouldn't be using my crayons, but you can use them. I would be probably using my pencils. Okay, just so that I can outline it, because we're going to use the crayons to shade things in later. Yes? Pogles are up here, so grab them, and then you'll just take pictures of them and put them up. I know the sub didn't know that we didn't pass in. So if you want to, but we're going to be using the crayons to shade later. So just know that this is going to be just an outline, just to give you a general outline of where the metals, nonmetals, and metalloids are. Yes? Livermorium would be in the metals. Yeah. So this part right here goes down here, and then, yeah. Doesn't really go on because that's all metals. So purple or blue, whatever you wanted to use. But really quickly, make sure you got the metalloids down, because that's a dividing line. So if you got the metalloids down and you just hint the color on either side, you'll have more time to fill it in later. I know some of you are OCD or CDO, because you have to have it in alphabetical order. But make sure you've got your metalloids down, because then you can go back and outline the other areas later. So boron, silicon, arsenic, tellurium, astatine, antimony, and germanium. Okay, the staircase plus 2 supporters, geranium and antimony. Okay, we're going to use basically our periodic table today is going to become a map. So we can use it to find different things on it. That's why I said don't color it in, just outline that. And then make sure that your metalloids are definitely shown, because metalloids are the dividing line. Very bottom is metals. 2 lines on the bottom across our metals. The lanthanum and the actinide series on the very bottom. Those are purple. Yep, those outline in purple.
Can you come help me? I think I messed up. And I think I need to do periodic table. First of all, that's not supposed to. That's why I just continue going
Right.
over it.
Right. So this is going to go here and then over and down. So I
Wait,
always
over
do
here?
the
Over here, 1.
Do your red first.
Did I do that right then?
Well, I already done all the purple besides. So should I just keep going over 1 more and then down?
Yep, because it's these ones right here. So you see the staircase right here, those
Yeah,
ones,
I
and
just thought
then
it
these
was a
two.
even staircase. That's why I started doing that. So what's that one red? Should I just bring that one in?
Yeah, do the red one first. So everybody get the red done first. Make sure you put your key up, and then just sort of highlight each side, or start a line on each side so you know what they are. I'm going to give you about another minute to finish that, and then we're going to go on. You should have your green packet out with you too, because we're going to be talking about different things in your green packet. And if I remember right, nope, I don't. So never mind. Okay, so you got that highlighted really quickly. Got awesome. Okay, make sure you come down this side too so you know. The bottom is purple, yep, or blue depending on what you took color-wise. Okay, everybody got their metalloids highlighted. That's the one that you need the most. Metals highlighted, and then make sure you've got a line of color on either side so you know what they're doing. I am recording this, so if you're having problems, you can go back up and look at it again. Okay, so it's not something that's going to go away. All right, last time, boron, silicon, arsenic, tellurium, and astatine. That's your staircase. The supporting ones are geranium and antimony. Those are your metalloids. Those are your metalloids. Okay. Now, as we go on the periodic table, there are only 2 that at room temperature are liquid. Okay, there are only 2 that are liquid. So I want you to pick a color. I don't care what you want to use as a color on your colored pencils. And you're going to put an asterisk. And you're going to just put an asterisk with that color on these. And up top you're going to say this is liquid. Okay, then you're going to pick another color. I don't care which. Doesn't matter what color you're coding yours. You're going to pick another color, and the ones that are in yellow, you're going to asterisk. And you're going to put up at the top, these are gases. And of course, our noble gases will be gases, all of them. Okay? For the yellow ones. The rest are solids, so we're not going to do anything with them. All we're going to identify are liquids and our gases, because everything else is solid. Okay, so just the liquids and the gases. We're not shading them, we're just doing an asterisk. So pick a color. It's like a star, or you could do a circle, or whatever you want to use to be your symbol. But just put it off to the side in that box. And you're going to show, these are my gases. Okay, so we're making a map out of our periodic table, so we know where things are. Again, I'm going to give you about 2 minutes to do that. Once those 2 minutes are up, if you don't get finished, this will be up on Canvas, and you can re-look at it and finish yours on Canvas. Okay, so make sure they're in 2 different colors or 2 different shapes. That would be fine if you want to do 2 different shapes instead of 2 different colors. To show one's a gas and one's a liquid. And then put a key up top so you know which one's which. So you should have 5 things on your key so far. What's a metal? What's a nonmetal? What's a metalloid? What's a gas? And what's a liquid? The rest are solids. So if you remember just the rest are solids, you're good. Okay, we got 1 more minute. I'm going to wander around the room one more time so I know that I give you at least a minute. Takes me about a minute to get around the room.
Can we do like 5 more minutes? I'm still behind this step unit.
Okay, remember we're just outlining right now to start with.
Wait, how can the BR be? Oh, wait.
BR is a liquid. BR and HG are liquids. One is a metal, one is a metalloid. Okay, we're coloring our periodic table, so please get going on it. Yes? So metalloids, tellurium, and astatine, and antimony. So these 3 you still need to add. And this is yours, but you need to finish it and upload it.
Okay, so I got this all done. Now what do I color?
Now you're doing the metals, are the liquids and the gases.
Liquids and the gases.
So you're just doing an asterisk.
What's the key really quick?
So
Purple
metal.
Purple is metal.
Red is metalloids.
Oh, what's the difference between those?
Metalloid. We'll talk about those in a minute.
Where's my pencil?
So these 2 are purple.
Those 2 are purple. Yep. Actually, no. This one is green. Sorry, because it's a noble gas.
What's green?
Okay. So the liquids are mercury and bromine. They should be asterisk or on your periodic table a certain thing. And the gases are hydrogen, the noble gases, and then this little L, NOF and Cl. So the last column and then NOF and Cl. Got it? Okay. So we're going to be having this periodic table be our map. We're still not done making our map. Okay? All we've done is just outline things. So this gets a little bit more difficult. So what I want you to do is go back into your, don't put this on your periodic table, go back into your notes, and either on the back of the green sheet, just do an outline real quick and put these names in. Okay, just do a real quick outline. It doesn't have to be pretty. So mercury and bromine are your only liquids. Mercury and bromine are your only liquids.
Where's mercury?
Mercury is 80, bromine is 35. Those are your only liquids. You just do a asterisk, a color of an asterisk.
Okay, where's...
Is OJ green or blue?
It should be green. It's okay.
Okay, so I get the star.
It's unknown, so I would put both outline, green and blue, because we really don't know.
And what color are all of these?
Okay,
They're all green?
those, no. So we're just doing asterisks on this, not colored in. Okay, and so the others, the gases, are NOFCl
So what do we color them?
and this. You're just going to take an asterisk, a different color, and do that. So these are liquids, and then you're going to do the others as gases. NOFCl, and then the last column, all the way down. Yeah, just do a real quick picture of that on your... where they are. You need to know where they are. So the first column is alkali metals. Second column. No. If it were me and I were doing this, this is how I would do it. I would look on my periodic table and I would go like this. Oh, first column. Second column. There's a middle thing. Okay, there's a next column here. Oh, see, I did that really well. Next column, next column, next column. 1, 2, 3, 4, 5, 6. Okay, then this one goes across and this one goes across, and I'd write their names in. Okay? It doesn't have to be perfect. I know those of you with OCD are just cringing right now, but all we need is the names of those columns. Okay? All we need is the names of those columns. So on the back of your green sheet, it's the best place to put that because it's got lots of room. So I'm just going to erase this real quick. Get out of your way. We're going to talk about these families, and you need to know what I'm talking about when I'm talking about these families.
So we agreed to color yellow.
Nothing yellow.
Oh, so this
Nothing
is
yet.
everything you need
Yep, right.
Up to date.
Now put that back and now grab
So I'm
your...
up to date?
Yep. Grab the back of your green sheet.
I'm going to redo it later, but...
That's okay.
I just need.
Back of your green sheet right here. Really quickly draw a periodic table, just overview like I just did. Really quick. So
Like
just
that? Oh, you did?
yeah, but it doesn't have to have the horizontal lines.
Just the vertical?
Just the vertical. And just that middle section that's sunken just needs one big section. Yes. Bottom will be purple. Yes. Okay, it doesn't have to be perfect. All you need to know is what the columns are called or what the area is called. That big area in the center that's sunken, that has 10 across. You don't have to show 10 columns across. You just need to show that whole big area is called the transition metals. Okay, so the first column is called alkali metal. The second column, and you don't have to put family on it either. So you can just put alkali metal. Second column is alkali earth. Then the transition metals, if you want to put metal. The lanthanide series is the first one on the bottom. The actinide down here on the bottom. This is boron, carbon, nitrogen, oxygen, halogen, and noble gas. They're all families. Okay? You don't have to put family on the end. You can say the families of the periodic table at the very top, and you know they're all families. Okay? Another name for family on the periodic table is called a group. It's just elements that have the same kind of characteristics. The elements that will react the same when I put them with different things. So if we know the families on the periodic table, we know which ones will react the same if I put them in the same situation. For instance, alkali metals, if I put them with water, they're explosive. Okay? They don't like water. So if you look at lithium and I put lithium in water, it's not as aggressive with water as cesium is. Lithium will just sort of sit there and bubble and give off hydrogen gas. As I go down, sodium starts giving me a yellow flame and starts popping around and giving me a few sparks. When I get to potassium, I've got a purple flame, lots of sparks, it's popping around and probably will give me a little pop. When I get to rubidium, I'm now starting to blow things up. When I get to cesium, just a little teeny bit of cesium in a bathtub of water will blow that bathtub of water and leave a crater. Okay, so francium doesn't hang around. Its lifespan is so small, it's 0.00009 seconds. It's so small as far as when it's alive that we can't get it into the water fast enough to find out. Hydrogen is its own beast. It's like floating above the table. It belongs to the alkali family, but it also sort of belongs to the halogen family because it's one away from being a noble gas. So it's sort of its own little family. It sort of does its own little thing. Okay, alkaline earth metals, which are next, they also react with water, but they're very slow in reacting with water. As I get down to barium, it reacts faster than it does with beryllium. You probably understand calcium more because calcium reacts with water, but it also falls out of water as hard water deposits. Okay, so how are we doing? Have we got all those names down? No. And that was a chorus there. No. The lanthanide and actinide series, those are more recent elements, and those elements have helped us be able to get the computer, be able to get all the new things with our phones that we've been able to do. Those are the elements that help us with the technology. Before that, when I was a kid, we didn't have those. They were just discovered. We didn't know what to do with them. We thought they weren't useful. Sort of like what we've got from 113 to 118 right now. We don't know what to do with them. We've discovered them, but we don't know what to do with them. As we get farther along on moving along with working with them, we'll figure out how to work with them. All right, we okay? I've talked and talked and talked. Come on, guys. Okay, so let's go back and talk while they're writing down the formulas about what's the difference between a metal, a non-metal, and a metalloid. So, metal, that's probably what you're most familiar with. Tell me, what are some characteristics of a metal? How do I know it's a metal? It can heat up. It can conduct electricity. It can conduct heat. It can move things around like that. What else? What tells you it's a metal? Okay, bendable. The fancy word for bendable in science is called malleable. So if it's malleable, it's bendable. Okay, anything else? Think of a metal. How would you describe a metal? Taste metallic. Well, I'm not going to be tasting metals, but okay. Did you have something? Okay. Give me something.
Okay, it's like hard.
Okay, it's hard. The only metal that's not hard, well, that is not solid, is mercury. And that's also known as quicksilver. Okay, because it runs and it's silver. Okay, the other metals, the alkali metals, the lithium, sodium, potassium, I can cut it with a butter knife. So they're solid, but they're not really hard. Okay, so hard is relative there. Okay, how else would you describe a metal? What color is metal usually?
Oh, gray.
Silvery gray. Most of the metals are a silvery gray. Some of them have a little blue tinge, some of them have a little gold tinge, but they're all silvery gray. Okay? They're also what they call ductile. Does anybody know what that word means? That's a big word. Ductile. It's what? Ductile. What does ductile mean? It's sort of weird. Ductile means it can be pulled into a wire. So you got two new words today. Malleable, which means what? Bendable. And ductile, which means you can pull it into a wire. So those are metals. Now, think opposite of metals. If it's not a metal, how would I describe it? Well, let's look on that. On the upper side of the staircase that we drew in, we have like nitrogen, oxygen, fluorine, neon, sulfur, phosphorus, chlorine, selenium, bromine, iodine, all the noble gases. So what could I describe a nonmetal as? Because I've got gases, I've got liquids, I've got solids, all of those in there, right? What do nonmetals not do? Do they conduct electricity? No. Do they conduct heat? No. What do? They insulate. These are things we use to insulate things, to make it so it doesn't conduct heat, doesn't conduct electricity. So these are our insulators. They're also very crumbly. They're more, when they're solid, they're powder. So if you've ever seen sulfur or phosphorus, it's powder. So sulfur would be like gunpowder. Okay, so you're thinking powdery. When I go to hit it with a hammer, if it does get a rock, and I hit it with a hammer, if I take a sulfur clump and hit it with a hammer, it just shatters. It just goes right to powder. It just shatters. Where metal, when I hit it with a hammer, it goes to whatever shape I've hit it with, right? Another thing is they've got tons of different properties. I can go at carbon, and carbon can be like coal, and I hit it, and it shatters. Or it can be like graphite, and I hit it, and it doesn't do anything but slip, because graphite's used to make things slippery, right? Those of you that have done Pinewood derbies, cars, you put graphite in, right? To make it go faster. Or it can be really, really strong like a diamond, and I go to hit it, and it does nothing. So it depends on how it gets to put together. So what do you think a metalloid would be then? We've described a metal. We've described a nonmetal. What would a metalloid be? In between. This is where our semiconductors come. This is also where our computers come. Okay, this is where it conducts, but not too well, so I can get some things going a little bit in between. These are where my semi-insulators are. So it will let some things through, but not everything through. Okay, so these are my in-betweens. All right, we got this all written down now, I hope, because I gave you lots of different times there. Okay. Yes, ma'am.
On the coloring, could we do our own colors that are our real colors, or does it have to be the purple, red, and green?
Well, you'll see here in just a second why I picked those colors, but yes, you could choose your own as long as you label it. Okay, I need you to get these four colors out. I need to get a yellow, a green, a red, and a blue or a purple. I don't care what you use on the bottom. I couldn't get it to color real well. Okay? On these ones, I want you to shade very lightly. Shade very lightly these areas. Okay? Shade very lightly. Please notice that helium is yellow. Please notice that helium is yellow. Okay? So just shade very lightly. You want to be able to read everything underneath this, but shade very lightly these areas. We're going to add some numbers to it too. So in a minute we'll use black and we'll add some numbers. And this is all preparatory to what we're going to be doing here in just a minute, finding out where the electrons are and how they work on the periodic table. Did Kate, John, Alex, or Miley come in yet? Come get your electron configuration. You need to upload it. We have some time here. And we might not have a lot of time in class today to do other things, but that's okay.
We shade it like that?
Shade it like this, yep. Today's going to be a mostly direct instruction day.
What do we upload the...
It's called POGL. It's called the Electron Configuration POGL on the first day. And I do have the iPads up here. If you do need to grab them, you're more than welcome if you finish coloring and nobody's done. And this is where I'd use my crayons because I can shade crayons really lightly. You want to make sure you're shading it lightly because you've got to be able to see the numbers underneath. So especially on the dark colors, the blue and the purple and the green and the red, you want to be able to see those numbers underneath because those are important too. So we did have it outlined for metals, nonmetals, and metalloids, and we also put on there for solid or liquids and gases, and we've written down the families on the periodic table on the green sheet, and now we are doing orbits is what this is called. We're going to be talking about the orbits on the periodic table. So these areas we're shading right now are orbits. So go ahead and get those shaded. I'm going to tell you what each area is representative in just a minute. Okay, to also help remind yourself, there's those two asterisk areas right here. If you use blue or purple, just go ahead and highlight those and shade those in too right there, if you would, with whatever your bottom color is, whatever that color is, your blue or your purple. Whatever that color is, because basically the periodic table, as you're looking at it, should be really, really long because those two below should be fit in where those asterisks are. But we don't fit them in, we just put them down below. So this is to help you remind you to go down to that color down below. Does that make sense? And I'll tell you why here in a minute, because we do need to keep track of them. Okay, I'm going to start adding things to this shaded area. Please make sure you add what I do. The first one's really easy. We're just going to add the number 1, 2, 3, 4, 5, 6, 7 down the left-hand side so we can count the rows. Then we're going to go in one. We're going to add 3, 4, 5, and 6, and then 4 and 5 down here, and 2, 3, 4, 5, 6, 7 in between right here. So I've added some numbers. Go ahead and add those numbers to yours. Hopefully you can see them. So first column by the yellow, 1 through 7. 4 and 5 down here, 5 and 6 up here by the green. So this one's right here. I'm going to just sort of, this is 5 and this is 6. But when it comes down here, it's 4 and 5. We'll talk about that later. It's okay. Yes?
What number is
HE is on the 1, is a 1. Whatever color you colored down here, color this area here so that it's the same to remind you to go down. Okay, I'm going to add a couple more things. I'm going to put an S equals 1 on the top here and draw my best description or best drawing of a sphere. Okay? Yeah, with black. Right above the D somewhere where you haven't got the other stuff, you're going to put D equals 5. You're going to do 4 are equal to a clover leaf, and 1 is equal to this funny thing with a donut around the center. Above the green thing.
Those are not. One? Wait, that's the number 1? I see number 4 with clover.
So 4 is equal to a clover, and 1 is equal to this dumbbell thing with a donut around the center. Okay, and then above the red area, we're going to call that P. It's equal to 3. And it is a dumbbell shape, but it is like a balloon. So somehow show that it's like 3D. It's like 2 balloons stuck together. Okay? And just put these on. We'll explain them in a minute. This is F is equal to 7. And we're not going to worry about the shape for those ones down there because they get really complicated.
The green area you put 4, 5, 6, and then the 5, 6 areas would be the blue area, but then you put 4, 5.
Just do it. I'll explain in a minute. Just put the numbers up here. This is just our map. I'm going to explain the map in a minute. So once we got our map made, we can explain it and go forward. This part of our map has to do with the shapes that the electrons travel in and what orbit out from or what shell out from the nucleus they are in. So the S is the first level out in any shell, and it's always a sphere. So it's just going to be a circle around the nucleus at that level. The next level out, or the next thing out in that level is what we call the P. And the P electron then goes in a dumbbell shape, but it's like 2 balloons, like it's going on the skin of 2 balloons. So it doesn't go on the inside of the balloon, just on the skin of the 2 balloons. And it's more on the outside edge of those 2 balloons, where you can find the electrons. The D then is a 4-leaf clover pattern, and it goes on the X, the Y, the Z, in between the X and the Z kind of thing going on, and then you have the dumbbell-shaped weird one. This is basically where I can find the electrons, and it's always on the outer skin. So think of them, the 4-leaf clover, as being 4 balloons hooked together in one plane. Okay, and it's mostly on the outer edge of the balloons that you find where the electrons can be. And then we get down to the F, and the F has basically 6 balloons, and it goes in all kinds of weird shapes around the X, Y, Z axes, but we're not going to worry about it. We're just going to say it's the F. Okay? How are we doing? Has everybody got all the numbers written down? It's important that you have the numbers and the shapes and the S, P, D, and F and how many there are. Now, if you'll notice, I have S is equal to 1, but there's 2 across. And P is equal to 3, but there's 6 across. So this is like when you were doing your electron configuration POGL last time. These are like the rooms. So in the S, there's 1 room. In the P, there's 3 rooms. The D, there's 5 rooms. In the F, there's 7 rooms. These rooms are called orbits. And in the orbits, I can have an electron spinning a positive spin and an electron spinning a negative spin. But that's it. So these are like the bunk beds. 1 up, 1 down. Okay? So I can have that many electrons in. Are we okay to move on? Make sure you've got the numbers written down. If you don't have the numbers written down, please write the numbers down. Yes. Yes, we're going to get there. Nope, we're going to get there. Okay? Make sure you've got these numbers written down. This is really, really, really important because this is where everybody screws up if they don't have the numbers written down. So 1 through 7 here, 3 through 6 here, 4 and 5 on the bottom. And then when you get to the beginning of the red, 2 through 7. And make sure you've labeled S, D, P, and F. And again, if you get behind, I am going to save this and put it up on Canvas, and you can re-watch it again. Okay? So you can re-get it what you need.
What is 1? 1 equals, like, what is that?
1 equals, it's sort of like a balloon with a donut in between it. I am not an artist, so that's my best description. It's like two balloons with a donut hook between the two. So they're a little bit farther apart than what the P would be. Okay? Okay, we're going to go ahead in about 20 more seconds. So if you haven't got this written down, maybe you can get it from a neighbor. Because we're actually going to start using it now. We're going to put the electrons in orbits just like you did last time with the POGL. Okay? Here we go. So, as we look at it, this is a little bit different color, but this is what's happening. The S block, the D block, the P block, and the F block. We're going to be putting electrons in. And as we put electrons in, you notice the atomic number was the number of protons, right? So when I get done, I should have the number of protons in arrows. So, we usually put the F block up in here. That's why, Tad, you color that little asterisk part. So you know it goes in here first before you get to here. The thing is, as we go out to the 6th level, we actually go back down 2 levels to the 4th level and then fill the F there. It has to fill according to the amount of energy it takes to fill the electrons. So that's why it goes down a level to get to D. It goes down 2 levels to get to F. It's called Aufbau's principle. And Aufbau's principle basically says I got to fill the lowest energy level first. Well, it's sort of like at home. Mom wants me to clean my room. Well, how clean? Well, Mom's in one of those moods, so it's going to be really, really clean. Or Mom's not really watching today, so it's going to be not so clean. It's one of those energy things. I got to know the energy level that I need to end in. How much energy is it going to take? Then we've got Hund's rule. This is the beds. Okay, when we did the beds, this is the beds. So we know that we need to fill 1 in each room first at the same level before I go back and pair it. I can't do this because kids, if I was in a dorm at school, would rebel because there's an empty room and I have to share a room and we're all on the same floor. What are you thinking? You know, give me my own room. So we need to have our own room. That's Hund's. So Aufbau, fill the lowest. Hund's, 1 in each room, then pair it up. And Pauli is the 3rd rule. And Pauli, you learned, was I can't have 2 on the top or 2 on the bottom. They've got to be 1 on the top bunk, 1 on the bottom bunk, right? There's just not enough room to have 2 either way. So when I fill a bedroom or an orbit, I need to have 1 up and 1 down. Okay? And always, I get my own room, oh man, I got to share. Okay? So that's how our arrows are going to go in. So not so far, other than just really quickly at the bottom of the first page, it said Aufbau's principle. Let's go back over it. Who can tell me what Aufbau's was? Yes, what was it? Fill the lowest energy level first. Good. So we've filled in Aufbau. Okay, what about Hund's? Hund's is the bus rule. 1 in each orbit. Right, 1 in each orbit first at the same level before I go back and pair it. Okay, and the last one, we just talked about Pauli's. I got my own room. Oh, shucks, I got to share. Okay, so 1, they have to be opposite spins. So opposite spins. So that was Pauli's. Aufbau was fill the lowest energy first. Okay, so let's go back up to how many electrons does each orbit hold? Because I did talk to you about this, but we didn't fill it in. Pauli was 1, they have to be opposite spins. Okay, so S. S has 1 orbit. So I want you to put this all in there. S has 1 orbit. That orbit can hold 2 electrons. That's what the number 1, S equals 1 above the yellow is. Okay, then we have P. What's above the P? 3. There are 3 orbits. Each orbit holds 2 rooms, so how many total electrons? 6. 3 times 2 is 6. Okay, so, but each orbit can only hold 2 electrons, right? And they have to be opposite spin. Okay, look at the D. Tell me about it. 5. 5 what? 5 orbits. Good. So how many electrons? 10 electrons. Pretty easy. Okay, what about F? 7 what? Orbits. Good. What does that tell me? How many electrons? 14. Yeah, right. 7 times 2 is 14. Great. Okay, so flip the page so I know what we're doing next.
Wait, what was S?
S was 2. F was what? So 1 orbit, 2 electrons.
What was D again?
D is 5 orbits, 10 electrons. Okay, we're moving on. Yes.
What's this again?
S is 1 orbit, 2 electrons. Fe.
P.
P, 3 orbits, 6 electrons. Okay, one more time for somebody that wasn't listening. Off-ball, what is it? Everybody, what is it?
Lowest energy level.
Lowest energy level filled first. Okay, what about Huns? Everybody. 1 in each room. So basically bus rule, everybody gets their own seat first, then fill it up. So 1 in each orbit, because that's what our rooms are. Okay? What about poly? Opposite spin. So 1 top bunk, 1 bottom bunk, right? Okay, which one goes in first, the bottom or the top? Top. Okay, make it happy. Okay, so basically positive spin first. Positive spin first, I got my own room. Negative spin, I got to share. Okay, we're on the next page. All right, so we're starting with orbital notation. Orbital notation basically talks about our orbits. Remember that I told you that S had 1 orbit. That's a 2. This is a 2s. So at the 2s level, we have a sphere. We also have a 2p on the x-axis, the z-axis, and the y-axis. So we have 3 orbits we can fill, each with 2 electrons, right? We're going to show with orbital notation how to put every single electron, show every single electron where they are, what spin they have, and what shape they'll be found in. That's what orbital notation is. Okay, so it's like the basis. So once we learn orbital notation, we'll move to a shortcut and a shortcut and a shortcut. Okay, but we need to know the basics. So here's my periodic table right here that I've colored. And we're going to take helium. And helium is up here on the far corner. Everybody find it on your chart. So you want to be watching your chart. Stay with me. You want to be watching your chart. Put your finger on it. You're on the second page also. You got your second page up. You got a pen or pencil in your hand. Got it? So you're finding this one right there. Okay, everybody got it. How many protons are in helium?
2.
How many arrows do you think I should have when I'm done doing the orbital notation for helium? 2. Good. So if I have 2, let's go look and see where helium is. Helium's right here. It's right here. Okay. I am starting on the first row in the S, right? And the S has how many orbits? 1. So I write it like this. 1s, and I put a line above it. Everybody okay with that? Okay, now I'm going to go to hydrogen. So I'm going to have 2. Here's my first one. I went through hydrogen. Okay, I've put the arrow in for it. I'm still not to helium, so I've got to come clear over here to helium to put the second one in. But I still need to have 2 in the room to fill, right? So I'm going to add 1 more in that room. I'm done. That's the orbital notation for helium. Okay, so let's try the next one for oxygen. Just put your finger on it, see if you can do it with me. So oxygen's right here. I'm going to erase helium's stuff right here. So oxygen's right here. How many arrows should I have? 8. I always start back up with number 1 though, because I have to start where I began. So I'm starting with number 1. And I've got to get to 8. So it's going to be at least like helium, right? That'll get me to 2. So I'm going to do that to get me to helium. I'm going across to helium. Then I come down to the second row. Second row, I hit an S. I put a 2s down. I put 1 line to represent that orbit. Okay? I'm going to go through that 2s, right? 1 up, 1 down. Everybody okay with that? I'm just showing the electrons. So I'm going to go 2s, up, down. Helium, or lithium and beryllium. Still not to oxygen, so I go across. I now hit the 2p. 2p has 3 rooms, right? How many into that am I? 1, 2, 3, 4, right? So I'm going to put 4. 1, 2, get out of the way. 2, come on. 3, and then I go back and pair it. 4. See how that works? Okay, let's do another one. Find silicon. Where's silicon on your periodic table? Find silicon, put your finger on it. I want to see if everybody's listening. Find silicon, put your finger on it. Come on. Find silicon, put your finger on it. It is in the red section. If you haven't found it, it's in the red. Okay, it is right here. Found it? Okay, how many arrows should we have when we're done? 14. Where do I start? First row again. So first row, I'm going to go through the 1s. I always start first row. So I've got to have 14 arrows. So the 1s, I'm going to have up and down. I'm still not to silicon, so I go to the second row, go through the S, and hit the P. So the S is going to have 2 in it. Now I'm at boron. So I'm going to have 4 to get to boron. Now I'm at boron. I'm going to make it all the way through the 2P, right? And there's 6 if I go all the way across. So putting in the 6 for the 2P, 1, 2, 3, go back and pair, 4, 5, 6. Now I'm at the third level, which is sodium. And I have to go all the way through the third level, which is S, right? 3S only has 1 room. Sorry about the little blue squiggle. I don't know why it wants to be there. So I'm going to put 2 in, 1 for sodium, 1 for magnesium. And I head across to the 3P. 3P, how far am I? 2. So when I get to the 3P, it has 3 rooms, right? But I'm only going to put 2 in. Done. Okay? You getting this? I want you to try and just on a scratch piece of paper somewhere on the corner or something. Would you do iron? Everybody find iron. Yes. I know we're going to be doing some others here in just a minute, but try iron right now.
Okay, but why didn't you go through this section?
Because I haven't got there yet. I'm just going on the rows. I just stay with the numbers, follow the numbers on the periodic table. And that tells me where to go.
So like the number beside it doesn't matter?
This number right here tells me what the S is, so that's the 3S.
But
This
then
is a
one
4S,
3S.
then 3D, and then 4P, yes. It does. I have to follow Aufbau's rule, so 3D is higher energy than 4S.
Okay.
But 4P is higher energy than 3D. So I have to fill it according to the order. Okay, if you have not found iron, here's iron. Whoops. Oh, I forgot to tell you, we're not going to really worry about this, but carbon is a special column. And remember that in your POGL, I think it's actually took 1 from the S and put it up in the P when P had an empty room? That's called hybridization, and that's why carbon can bond with 4 things. So sometimes if they're the same number here for the S and the P, it can still 1 from the S and put it up in the P. Because we're all on the third level, and there's 1 empty room, and why do I have to, if I'm just a half a step down from the P, 3P, why do I have to share when there's an empty room? That's sort of what's going on. But carbon's column's the only one that does it. And it only does it part way down, 3 down. Okay? All right, so iron, if you haven't found it, it's right there in the green. How are you doing? You figured it out? There should be 26. Good, and it's behind my thing here. Let's see if you filled it in right. Whoops. Is that what you got? I got it. I didn't get it. I'm sort of there. Okay, so let's go back and do yours. You did boron. Okay, so boron should have how many? 5. So when we're doing 5, let me bring up a white sheet because I did some that you don't have. I'm just bringing up a white sheet so we can write on it. It's being slow. Just thinking about it. Okay, I'm just going to put it off here to the side. Hopefully a little right on it. So boron has 5. It's right here, right? I can't touch the bottom one or the top one will go away. So if I'm doing boron, I'm going to have 5 arrows. So I'm going to start at the top. 1s. I'm going to go hydrogen, helium. Then I'm going to go around. I'm now at number 3, right? Everybody there with me? Following? I'm at number 3. That's on the second row in the S. There's one orbit. I'm going to go lithium, beryllium. Then I go across and I hit the 2p. 2p has how many orbits? 3. It has 3. I've got to show all 3 orbits. Whatever orbits I'm doing, I've got to show them. I only have to go 1 in to get boron, but I have to show all 3 empty ones. Okay? So let's do the next one. The next one is cobalt. Cobalt. Where is cobalt? Cobalt is right next to iron. You see it, number 27? So when I'm done, I should have 27 arrows, right? Somebody tell me what's the first thing I need to do? 1s. How many orbits? How many orbits? 1 orbit, 2 arrows. So that's hydrogen and helium. Somebody new. Tell me where I go from there. Yes? An orbit's like a room in your POGL. So a room is just where 2 electrons are held. So our orbits are going to be a sphere or a flower-leaf clover or 2 balloons together. It's just a room. It's just a shape of a room. Please put that away. I need you to be with us, please. Okay, so what's the next one we hit? What's the next room or orbit we hit? 2s, good. 2s. And how many rooms does it have in it? How many orbits does 2s have? Any s? 1. That's why we put s equals 1 at the top. So we're now at lithium. We're going to go lithium and beryllium. Lithium, 1 up. Beryllium, 1 down. Okay, now we're at number 4. We're going on to number 5. Following me on the periodic table so you can see we follow the atomic numbers. If you follow the atomic numbers, you'll never go wrong. Okay, with this. So what do we hit next with number 5? Where are we? 2 what? P. How many room does P have? 3. 1, 2, 3. And am I going all the way through that room? Or those rooms? Yeah, because I'm trying to get to 27. The end of that room is 10, right? That's neon. So I'm going to go 1, 2, 3, 4, 5, 6. I'm now at number 10. I'm going on to number 11. Where's number 11? Where's number 11 on the periodic table? 3s. Good. We're right here. 3s. Okay, how many rooms for 3s? 1. And I put in there how many? 2. Sodium and magnesium, right? So now I've done these 2. I'm now going across to find 13. Where's 13? Where's 13, guys? Right, what area is it in? 3. And what sub-level? P. How many rooms? 1, 2, 3. Am I going all the way through the 3P? Yes, so I'm going to go all the way through. That's 6. So 1, 2, 3, 4, 5, 6. I am now going on to number 19. Nope, number 19. What's number 19? My numbers are off a little bit. 4s. Good. How many orbits? 1. How many electrons? 2. So now I've gone through potassium and calcium. I now have 20 arrows up there. I'm still not to 27. Now I'm going to 21. What area is 21 in?
How do you know that you're going to 27?
Because I'm trying to get to cobalt. Cobalt's 27. Okay, so what is in front of scandium? What do we put in front of scandium? What number? 3, and we're in the D. How many rooms does the D have? 5 rooms. 1, 2, 3, 4, 5. Okay, how many in is cobalt? 7. So to get there, to get 27, I go 1, 2, 3, 4, 5, come back, 6, 7, I'm done. Okay, how are we doing? Okay, so now do magnesium. Okay, yours practice, do magnesium. And then chlorine. So magnesium and then chlorine. I'm going to put those up real quick in just a minute, but I want you to try them on your own. Try magnesium and chlorine on your own. That's not how we're doing it. This is not orbital notation. No. Orbital notation's with the arrows. So fix that and put it in arrows.
Are we going to fill it up like this, or like fill it up with just up arrows and then go back?
So whenever you have more than one room, you have to put one in each room first and then go back and fill it. So when you have the S, you only have one room.
Yeah.
So you can go up and then down and move on.
So for 2P, we're supposed
You
to
have to do one in each one and then go back and fill it.
Okay.
Okay?
All right.
Yes. A room is basically an orbit. So this is what S is one orbit. This has P has 3 orbits, so or 3 rooms.
How do you know where they are?
Just by the colors that we color coded. So you just follow your numbers to get to where you're getting, and whatever you have to go through. Pink P has 3, D has 5, and F has 7. So as you get there, you can say, oh, 2P, I need 2P underneath and 3 rooms, and then I go through and fill it with the arrows. So let's do magnesium. Magnesium is right here. So by the time we're done, we're going to have 12 arrows.
Right here.
So you're not going to get to the D.
Oh, wait.
Not manganese, yeah. Okay, so you're going to start at the top, and you're going to do one S and put one line above it. And then you're going to go hydrogen up, helium down as far as arrows.
4S.
Is that always going to be like that?
And then second row, so is 2S, and it's one room, and one up for lithium, and one down for beryllium. Then you come across to 5, it's 2P, and P has 3 rooms.
Yes.
And then you put 1 in each room, and then go back and pare it down, because we're still not there. Okay, and then the next one we hit is the 3S, and 3S has 1 room. Yep. Now you try the next one. Yes.
I don't really understand it. So magnesium is 12,
Right.
and then
So you're going to start at the beginning again with 1S,
the 1S.
real fast. So 1S, you're going to go 1 up for hydrogen, 1 down for helium. And then you hit here because now you've got 2 arrows. Now you're on to the 3rd arrow. So you're going to hit 2S. 1 up for lithium, 1 down for beryllium.
So it's
Following
not
across.
okay. And
Then you hit the 2P, and you put 3 rooms above 2P. And then you're going to go all the way through. So you're going to put 1 in each room up, and then go back and pare it down. So this would be up, 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 down, down, down.
And then it's down.
Go back and pare it, yeah. Now we're here, so now we're on the 3S. And we go up and down, done. Okay, try and do the next one.
Because I'm pretty sure we got it.
Missed one here.
How?
Because magnesium's the second one in, so you should have up and down.
So you do have the one.
You do count it, yep. Okay. Chlorine, it's in your book. It's in your thing right there. It's right there. Yep. Okay, so those of you that are struggling, let's do this really quickly with me and double check if you've got it. Magnesium, you should have 12. Starting at the very top. You always start at the top, okay? Always start at the top. So I'm going to start with the 1S. There's 1 orbit. Hydrogen, helium. I'm now number 3, which is 2S. Second row in the S. Lithium, beryllium. Then I go across, I hit 5, which is boron. Boron's in the 2P. It has 3 rooms. I'm going to go all the way through that because magnesium is not one of those. So I'm going to have 6 total, but I fill it. 1 for boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay? Then I hit the 3S. The 3S has 1 orbit. I go 1 up for sodium, 1 down for magnesium, and I'm done. Okay? Next one was chlorine. Chlorine is number, I can't read it. What number is it? 17. So we're going to have 17. So it's going to be just like magnesium. So I'm going to put magnesiums up there, and we'll start from where magnesium is, just to save some time. But it's basically the same as magnesium. Okay, now I'm at magnesium right here. All I have to do is go across right here to hit aluminum. Aluminum is where? It's on the third row. It's in the P. That means there's 3 rooms. How many in is chlorine? Chlorine is 5 in, right? So we go 1, 2, 3, 4, 5, and we're done. Okay, this is the long version. Okay, this is the long version. So if you get the long version, the rest are going to be really easy. This long version, though, tells us where every electron is, what orbit they're in, what spin they have. Okay, it also will tell us if it's magnetic or not, although we don't get there in Gen Chem, but they'll tell us if it's magnetic or not, because if it's paired or not paired. If it's not paired, it's magnetic. If they're all paired, it's not magnetic, which is sort of cool. The more unpaired they have, like iron has 5 unpaired, it's very magnetic. So anyway, all right, let's go on to the next part here. I did have them up there. We're just going to buzz past these. I did have that one up there. I'll just have to remember that I do have them up there. Okay, electron configuration is the next one. So orbital notation, arrows. Okay, but as a scientist, can you imagine doing one of these arrow ones for livermorium? It's a lot of arrows. Even when you're just using half arrows, that gets really old fast. So they came up with a way to do a shortcut. And the shortcut is just telling me how many are in each shell. Okay, so for nitrogen, let's find nitrogen. Everybody put your finger on it. Right there. Got it? It's in the pink or red, middle. Okay, how many arrows would we have had? 7. That's not too bad. But I can quickly shortcut it and say, oh, in the 1s, in the 1s, there are how many to get there? 2, hydrogen and helium. In the 2s, now I'm at lithium, right? In the 2s, there are how many to get there? 2. Then I go across, right? I hit the 2p. How many to get there? 3. So my exponents begin telling me how many arrows there are. Okay? Try yttrium. Okay, so I did nitrogen with you. Try yttrium. Do the same kind of thing. Follow the numbers, though. Follow the numbers, because then you won't go astray. I'm going to do it up here slowly in just a second for those that are really struggling. Okay? And I'm going to follow it through with doing the arrows here. So yttrium is right there, if you can find it. Yep. That's a 10. Okay, how'd you do?
Bad.
Were you able to figure it out? Notice what I did with the periodic table. See how I put the lines through it? If you follow with your finger, when you hit, and you start with 1s, 2, and you go through and you write 1s and there's 1, 2. And then you go down the second row, following the numbers. 2s, how many? 2. 2p, how many? 1, 2, 3, 4, 5, 6. 6. Then 3s, how many? 1, 2. Then go across. Aluminum. 3p, 1, 2, 3, 4, 5, 6. 4s, 1, 2. Then 3d, how many? There's 10 across. Then 4p, 6 across. Then 5s, 2 across. 4d, 1. And I'm done. Okay? If you add up all of the exponents, how many should I end up having? 39. Yes. Okay, does that make sense? Okay, so now you do the next one. I'm not sure. 2 minutes. Try it. Keep going.
I have a question.
Yes. Okay, so there'll be some of the practice and stuff you'll be able to do, and some you probably won't be. Let's see.
Where's Foster?
On like when we did this one, you just have to like count each
3, 6.
individual.
Yep.
Right?
1, 2, 3, 4, 5,
so
6.
not like the rooms like 1, 2. So that would be like 1, 2, 3, 4, 5.
There's 5 orbits, but there's 10 rooms.
Okay.
10 rooms. 10 electrons. Okay. So hopefully you're able to do this. I'm going to do this really fast. So phosphorus is here. 1s2, 2s2, 2p6, 3s2, 3p3. Good. Silver, right here. You do the same thing. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. I'm just following through. 5s2. That was a funky 5, sorry. 4d9. Follow the atomic numbers all the way through. I'm going to cheat real quick and go here. Okay, so the only thing that we didn't get to was noble gas configuration. I'm going to do that really quickly. Yes, it's so easy, guys. Let me pop really fast to you. Where's your noble gases? Where's your noble gases? Very right side, right? Very far side. All we're going to do is take this big, long thing right here. We're going to take the noble gas that's closest to without going over, so you play the prices right. You put it in brackets. And then you list everything past that. Okay? Now, the funky thing about this is you do have to rearrange it according to shell out, because noble gas configuration is done so we know what ones are going to react. So we would redo this one and say it's like xenon, but it has, in the 4F, it has 14 more electrons. In the 5D, it has 9 more electrons. And in the 6S, it has 2 more. Because the farthest ones out are the ones that are going to react. So the 6S are going to react. We'll go more over this next time. Put away what you need to. Don't stand by the door. Just hang tight. You'll need to do the practice. I would get the practice done that you can do that is not the noble gas. If you understand the noble gas, great. I will put this up on the web. So I need to put... Yes?
What is the test on 30?